Okay, so let's look at two more numbers just to solidify the concept. Then I'll talk about negative angles. Then I think here we have 1 plus cos is equals to this. So remember this identity, cos squared theta plus sine squared theta is equals to 1. So we make sine squared the theta a subject. So we have 1 plus cos theta is equals to this. So now here what we're just going to open the brackets. Then I bring this side. So this is 2 cos plus cos theta 1 minus 2 minus 1 is equals to 0. So we have this. You let cos theta be maybe a. So 2a squared plus a minus 1 is equals to 0. You solve this. So you get a is a half and a is equals to negative 1. So what does that mean? But remember I told you that you have to show the working for how you solve the quadratic equation. So here you say theta is equals to cos inverse of a half. Put that into your calculator. Theta will be 60. Then now you draw the quadrant. When you draw the quadrant, what do you have? No, don't forget to put this in. This is 60. 60. This is 60. This is 60. This is 0. 90. 180. 70. 360. So then you put all students take coffee. Now here when you look at cos theta, it's positive. In our first quadrant, which it means all are positive including cos theta. So this is it. Then we look for another quadrant where cos will be positive, which is that one. Then easy marking, I'm changing color, but in a book it will be okay even if you just use the same color here. I just want to. So theta will be 60 degrees, comma 360 degrees minus 60 degrees. So theta is equals to 60 degrees and 300 degrees. So this is this. Then the second one was a is equals to negative 1. So cos theta is equals to negative 1. So remember I told you where you have negative 1 or 1 for sine or cos. You don't even have to waste your time drawing this quadrant. The best thing you can do is to draw this. When you draw this 1, negative 1, and in this is for theta, this is for cos theta. So you put 90, 180, 270, 360, negative 90. But since here we are not looking for negative angles, even if you stop there, it's okay. So last time I told you I draw a table, but you don't even have to draw a table. You just come to your calculator. This is 0. What is cos of 0? 1. I plot 1 here. I go to cos of 90. What's cos of 90? 0. Put that. I go to 180. What's cos of 180? Negative 1. And with enough practice, you can just even draw this graph without. This is cos of 270 is 0. Then cos of 360 is 1. So when you put this becomes this goes through that. And since we say that the graph of cos theta is symmetrical, so even without guessing, I know that this will also be like this, like that, because it's symmetrical. But okay, this is all that. So now I just look how to have cos theta is negative 1, so I come and mark negative 1, and I see what I have here is 180. So theta is 180. Theta would also have been negative 180 if my range was also going into negatives, but I don't need that. But I can even try and see what is cos of 180. It's negative 1, so it fulfills this. So I now just come and quote my values of theta. Theta is 60. Usually write them in ascending order, 180 degrees and 300 degrees. So we solved for theta. Now let's do the next question. And here what do we have? We have sec squared is equals to this. So usually here the clue is just in finding out how to break that term. Now here this is what we have. So we're going to, this is our range. So we say what is cos squared theta plus sin squared theta equals to 1. I divide through by cos squared theta divided through by cos squared theta, so I get 1 plus tan squared theta is equals to sec squared theta. So now I can just come and substitute here, though this formula should already, with time it gets into your head. This is equal to 3 tan theta minus 1, so you have tan squared theta minus 3 tan theta. This is 1 and this one comes plus 2 is equals to 0, so I can let tan theta be x. So I have x squared minus 3x plus 2 is equals to 0. You solve this, you get x is equals to 1 and x is equals to 2. So we start with tan theta is equals to 1. So theta is equals to tan inverse of 1. So I'm going to draw this. Zero, 90, 180, 270, 360. Then now I label my angles. This is so theta is equals to tan inverse of 1. What is theta? Theta is 45 degrees. Sorry, I didn't write that. So here this is 45, this is 45, this is 45, and this is 45. So all students take coffee. Then now here my turn is positive, so here and here. Then come this, come this. So what is theta? Theta is equals to 45 degrees, comma 180 plus 45. So what is theta? Theta is 45, comma 45 degrees, comma 180 plus 45, that is 225, comma 225 degrees. So I found, then I come for this second one. Tan theta is equals to 2. Is equals to tan inverse of 2. So what's the tan inverse of 2? So round off, this is 63 with 2 decimal places, 0.43 degrees. Then I draw. But here it's going to be the identity, same thing, just different angles. So this comes like this: 0, 90, 180, 270, 360 the degrees. This is 63.43, 63.43, 63.43, 63.43. All students take coffee. Then since it's positive, all, and then where turn is positive, so this goes there and this comes there. So what is theta? Theta is equals to 63.43 degrees, comma 180 plus 63.43 degrees. So theta is equals to 63.43, comma 243.43. Remember I told you can always prove. So when I come and say theta, I now quote the entire line of angles, usually in ascending order. So, okay, now I'm going to explain negative angles with 2 examples. So here I have this tan theta is equals to 1. Find theta for that. So let's first find the positive angle, since we've what we've been doing for almost the start. Tan theta is 1. So what is theta? Theta is tan inverse of 1. Theta is 45. So I draw the quadrant. The quadrant this. So this is 0, 90, 180, 270, 360 degrees. Then I put this. Okay, maybe I should clear that. Yeah, okay, so let me now have something like this and something like that. So this is 45, this is 45, this is 45, and this is 45. They say here all students take coffee. So here all are positive, here sign is positive, only sign is positive, here only tan is positive, here only cos is positive. From my equation, it's equals to 1, this is positive. So these are the two quadrants I need. So I'm going to go there, and then I also come here. So what do I have? I have theta is equals to 45 degrees, comma 180 plus 45 degrees. So theta is equals to 45 degrees, comma 180 plus 45. This is 2, 5. I said we can prove this by saying tan theta is 1. So I try saying what is tan of 45. Tan of 45 is 1. So I've put that is correct. What is tan of 2 to 5? I put this on the calc. Tan 2 to 5. This thing keeps going. This is also 1. So our answers are correct. Now I want to find the negative angles. So same thing. Theta is equals to tan inverse of 1. Theta is equals to 45 degrees. Now let me use a different color. Should have used the same drawing, but just for the sake of it, let me draw. So this, for the next one, I'll use the same diagram, I think, for both the positive and the negative angles. So we have something like this. Put 45. Remember, we said for the positive angles, we go in the anti-clockwise way. The negative angles, we go in the anti-clockwise way. So this is 0, 90, then 180, then 270, then 360. But if we were to talk about negative angles, this is 0, this is negative 90, this is negative 180, this is negative. I don't know if this makes sense. If we're talking about negatives, because we are going in this direction, in the clockwise direction. Okay, even if you don't even write that, just do the same thing. All students take chemistry. So even if you're looking for the negative angle, you still see tan theta is 1, it's positive. So you look for the positive quadrant, this and this. But this time, the difference is this time, to reach there, we use a different route. We come from this side, so we come like this, you see, like that. Then we come like this, then see, like that. So we are counting from this side. So when you're coming from this side, it's the same as saying theta is equals to, you put a negative, then you enter this bracket. This is 180 minus 45. So what is theta? Theta is 180 minus 45 is 1 theta. This is negative 135. Just a negative angle. Also, theta is equals to, for this one, we are going to say this is negative 60 degrees minus 45. So theta is equals to negative 360 minus 45. This is negative 315 degrees. So now let's say what is the tan of negative 135 degrees. So we put on our calculator, that's the tan of negative 135 degrees. It's 1. So you see, this shows we are on the right track. Then we test also what's the tan of negative 315. Tan of negative 315. It's also 1. So you see we've proved that. Now we have this question. Now I think for study purposes, maybe I'm going to make this is equals to tan theta is equals to negative 2. So now here we'll say theta is going to be tan inverse of negative 2. But remember, I told you that every time you have a negative, you consider, because getting the tan inverse of negative 2 won't give you the answer. So you consider theta is equals to tan inverse of 2. You have to say consider because this is not what the question was asked for. So the examiner should understand you're not trying to find the answer, you're just part of your working. So from the calculator, you round it off to 2 decimal places. This is 63.43 degrees. So we have 63.43 degrees. Then now we draw our quadrant. Remember I told you for this one, I want to do them on the same diagram. So this is 0, 90, 180, 270, and 360 degrees. So we have this, we have this. This is 63.43 degrees. This is 63.43, 63.43. This is 63.43. And we say all students take coffee. Now, when we look at this, our tan is a negative, like tan is equals to -2. So we look for the quadrants where tan is negative. Here, all are positive, so you don't want this. Sine is positive, so only sine is positive, so meaning tan is negative. Here, tan is positive, we don't want this. Here, only cos is positive, so tan is also negative. So these two quadrants. Now, the question has already limited us to 180, but I want to show us both. So for the first one, the positive angle, this, the second positive angle will go up to this. So what will theta be? Theta will be equals to 180 minus 63.43. So these are degrees, comma, though the second one wasn't necessary, comma, 360 degrees minus 63.43 degrees. So what is theta? Theta will be 180 minus 63.43. And here I get 116.57 degrees. And here I get 296.57. So I have these two. Now I want to get the negative angles. So what I was saying is, to get the negative angles, the quadrants don't change actually. Because here, for the negative angles, yes, you go anti-clockwise, you go clockwise. So for the negative angles, I come like this, and then I come like this. Another thing you should notice, we are like calculating the distance covered. For this, the distance covered is this, coming from this side. That's what I think many students find confusing. So that's why here theta is going to be negative 63.43 degrees. Then for that second one, theta will be negative 180 plus 63.43. Because so theta here will be 180 plus 63.43. So theta is equals to 243.43 degrees. So I was saying the simple way to think about it is just assume they want the distance covered. In this case, it's this whole thing coming from this side. So these are our answers. So we now just have to list them. As I told you, you have to list. So you say theta is equals to negative this. But for now, I'm going to just pick out the correct ones because the question had given us a range. I just added this for an example, but you can try and prove with this. Let's say, what is tan of negative 63.43? Let's try it and see. Tan negative 63.43. This is negative 1.9995. So you see, this approximate is, so you see what I'm telling you. So even the negative angle is, so even we can try tan. So that is just an error from rounding off this. You can try it on the calculator. So I think you can see with this, you can find as many angles as you want. It's just the question that limits you. Even this gives you the same thing, negative 1.99568, like that. This whole thing is approximate. So this is how you find the negative angles of a quadratic equation. Alright, so now this is going to be a simple exercise for us. So you can try this out, and I think I may. Now for this one, the solution is going to be the exact same thing except for one small thing, and I think I can talk about it now. So here we're going to work this out, and you'll have, maybe you change this to maybe what is cos squared theta plus, okay, let me write it here, this is equals to this. So you treat it like any other thing. You say cos squared 3 theta plus sine squared 3 theta is equals to 1. So cos squared 3 theta is equals to 1 minus sine squared 3 theta. So you substitute this here, then you make a quadratic equation in the form of sine squared 3 theta. Then you let sine 3 theta be x. You solve the equation. Then after you have maybe sine 3 theta is equals to, I don't know, maybe a number, maybe like a half. I'm not saying it's equal to half, but a number like a half. Then you will solve. Now the angles you'll get will be 3 theta is equals to maybe this angle, this angle, this angle, this angle. Now you divide through by 3. Now at the end of this chapter, I think at the end of this video, I'm going to display the answers to all these questions, this, and this, such that you can compare and confirm. Yeah, so here we have angular measure in radians. So here you see the question I said, they have asked you, but they have said they want the answer in radians. So how do we find radians? So just now 360 degrees is equals to 2 pi radians. Then if you divide through by 360, you realize 1 degree is equals to pi out of 180. So if you multiply any angle by pi out of 180, you change it into radians. So whichever answers you get here, divide them by 3, so that those are that you get theta in degree form. Then you multiply it through by pi out of 180, change it to radians. And yeah, if you change it to radians, then you'll have solved the question when the examiner wanted. Okay, so these are the answers to the questions as we said. So we have this, yeah, and for this one, 2 cot squared plus 8, I think you would use the other relationship from cos squared theta plus sine squared theta is equals to 1, but this time you divide through by sine squared theta. Sine squared theta, so you have cot squared theta plus 1 is equals to cosec squared theta. So you can make cot squared a subject, you substitute it there. I think the rest makes sense from the concepts we've covered so far.